This one, I remember, my Calc 1, you guys know what a common final is? Yeah. We were talking about it before, where all the professors get together, write one test for everyone in calculus. Those are the very hard exams because everyone in calculus takes exams at the same time. I remember, okay, keep in mind, this has been, let's see, I took Calc 1 my freshman year, first semester, so that would have been 2000, year 2000. Okay, so 13 years ago, which is the end of the year 2000, I took this exam. I still remember the back of the test was this. And I knew it. I'm like, oh, I just studied that because I actually had a study guide they gave us, and I didn't get it, but I still remember getting to that and be like, you know, panicking at first, and I'm like, oh, okay, no, I didn't have to do this. Yeah. But this was the back page. I mean, I can't believe I remember 13 years ago. I can picture it clear as day where it was on the test. No, different numbers, but yeah, the same question.
Did it have example 3 or something?
Huh? I didn't hear what you said.
Did it have like example 3?
Yeah, exactly. That's exactly what I had. But this is a very, I want to emphasize to you, this is a very typical problem, and I did talk about this yesterday in cones, where we have, you're filling it with water, you're eating ice cream, you're pouring a sand pile. They're almost always when you're talking about related rates, you're going to have a problem like this. Okay, so it's definitely need to know how to do it. So water runs to a conical tank. By the way, conical is cone.
Okay, cool.
Okay. At a rate of 9 feet cubed per minute. The tank stands point down and a height of 10 feet and a base radius of 5. So how fast is the water level rising when the water is 6 feet deep? So I've got a nice neat cone here. Maybe it's suspended. No. We'll say it's hanging. Alright, so water runs in at 9 feet cubed per minute. What are they giving me there? The rate of what?
H.
But it's the volume.
Volume.
The volume. This is your hint right there. Look at your units. Isn't that units you would give for volume?
Yeah.
And you're filling water, so it is the volume. So we know dV dt, and it's filling it up, so it's positive 9 feet cubed per minute. If it was draining from the tank, it would be negative. Yeah. The tank stands point down, height of 10. So this is 10. That's not changing. The tank itself is not changing size, correct? So then the radius is 5. That is not changing. Those are constants. I can plug them in at any old time. They are constants. Now, how fast is the water level rising when the water is 6 feet deep? A lot of people get confused here because they don't think we have any variables. But just remember we were talking about the water level. So this is the height of the water. This is the radius of the water, correct? That's what is changing. The tank is not changing, the water level. So when they ask me to find the water, how fast is the water level rising? What are they asking me to find? The HDT. The water level, that's my height. So I want to find the HDT when H is 6. You follow that?
Yes.
Is 6 constant? No, it's at that one moment. Okay. So we have our setup here. So now what is my equation? D equals
1/3 IR squared H.
IR squared H. But here's the problem. This is what most people struggle with the most. Is rates. When we're talking rates, how many variables do I have in this equation? 3. And one of them is what I'm trying to find, right?
Yeah.
Which means I would have to have the other 2 rates. I do not. Now, in the last problem, I was missing a variable, and we were able to find the variable, correct? But if you're missing a rate, there's no way to find the rate. Just not possible. So that tips to you that I am missing a rate, because I'm finding one, I have one, but I know nothing about dRdt, correct? And I can't find it. So what that tells me is I need to eliminate if I don't have its rate and I need it, I have to get rid of the variable. Okay, let me say that again because I see some looks here. That I have three variables. I'm trying to find one of the rates. I'm given another. I would need drdt. But you can't find drdt if you're not given it. You can't find a rate. Unless it's what the final question is. So I have to get rid of it. So I don't have drdt. I have to get rid of r. Any ideas on how I could eliminate r?
Just take it out.
Just take it out? No.
There's no
It's gone. Yeah, just throw it out. No.
Solve for it
Solve for where?
in the volume equation.
Won't that still be in there? Because it'd be r equals. So when I differentiate, I'm still going to have drdt.
Make it a constant.
Well, it's not a constant though.
You use the original radius.
But it's not constant, so no. No circumference.
Find the derivative set equals 0.
Make that. Does not
Oh,
exist.
there's a triangle there.
Oh, isn't that a triangle in a triangle? Couldn't I use a proportion?
Yes, yeah, I thought that.
That's not saying.
Oh,
I thought that, but I thought
okay. 5 is to 10 as r is to h, correct? Side to bottom, side to bottom. Okay, so let's cross multiply. Okay, I have 5h equals 10r. Solving for r, so r equals h over 2. Everyone agree with that? Now let's plug that in over here.
Ah.
And don't be a fool. Some people try to differentiate here. Let's clean it up first. Okay, so I don't have to use the power or the product rule. So that'll give me 1/3 pi h squared over 4h. Correct? Let's keep cleaning that up. So I actually have, I'm going to go and put pi over 12 h cubed. Right? Pi over 12 h cubed.
Hey, look at that.
That's a nice, neat function to differentiate.